It is now your turn to try to solve a quadratic equation, finding all real or complex solutions to that equation. Please pause the video, return to your lecture notes packet, and attempt this example on your own first. Once you have attempted it on your own, please then return to the video to check your work. We need to find all real or complex solutions to the quadratic equation, in parentheses y plus 7 squared equals negative 40. Recognizing that there is only one variable in the entire equation, and it is caught up in that squared component, and that squared thing already equals a number, this equation is already set up for us to use the square root property. So the first step in solving the equation, quantity y plus 7 squared equals negative 40, is to apply the square root property. If this y plus 7 squared equals negative 40, then what is being squared, in this case y plus 7, is either equal to the square root of negative 40 or the negative square root of negative 40. There are two steps left to solve either of these two new equations, y plus 7 equals square root of negative 40, or y plus 7 equals negative square root of negative 40. One step is to isolate the y, the other step is to simplify the radical. It does not matter which order you do those two steps in. I personally tend to first simplify the radical so that it can be on its own on the right side of the equation. The first step in simplifying the square root of negative 40 is to bring the negative 1 factor of that radicand into its own radical. So we'll rewrite the square root of negative 40 as the square root of 40 times the square root of negative 1. On the left side of the equation, though, we still do have y plus 7. So our second equation in total becomes y plus 7 equals the square root of 40 times the square root of negative 1. To continue simplifying the square root of 40, 40 does have a perfect square that divides into it, which is 4. 4 times 10 is 40, so we will rewrite the square root of 40 as the square root of 4 times the square root of 10. Keeping everything else in that equation, we'll then have y plus 7 equals the square root of 4 times the square root of 10 times the square root of negative 1. So again, looking on just the right side of the equation, the square root of 4 simplifies to 2. The square root of 10 cannot simplify any further because there is no perfect square that divides evenly into 10. And the square root of negative 1 becomes I, giving us 2 times root 10 times I. So our whole equation is y plus 7 equals 2 times root 10 times I. So there are two things left to do in this equation. One, we need to get the y by itself. So to do that, we're going to subtract 7 from both sides of the equation. And when we subtract 7 from 2 root 10 times I, we're going to reorder things a bit. I'm going to put the negative 7 in the front. Then I'm going to have plus 2i root 10. It is fairly standard notation to have the radical factor or the radical term be the final piece of your expression so that it's clear what is and what is not under the radical. So our first solution is negative 7 plus 2i root 10. Now to do similar work for the second solution that starts with y plus 7 equals negative root negative 40, a lot of the work is going to be very similar. So I'm going to take a shortcut on some of this work. I'm going to take all the work we did to simplify the square root of negative 40 into 2i root 10, all of this work, and I'm going to take that as a given when I go to write my second solution. So my first step of work on the second solution will become y plus 7 equals negative 2i root 10. All that occurred from going from that first line to the second line is the exact same simplification we've already done over on the left side of this page, and so there's no need to reproduce all of that work again. So the final step in solving this equation is to subtract 7 from both sides of the equation. So if we have y plus 7 equals negative 2i root 10, we'll then subtract 7 and end up with y equals negative 7 minus 2i root 10. Recognizing now that we have the two solutions identified, we're going to now rewrite this as a single solution set, and there are two ways we can write this. One is to write it as the solution set is the set negative 7 plus 2i root 10, comma, negative 7 minus 2i root 10. The other option is to use notation similar to what we see in the quadratic formula, where we end up with that plus or minus notation. And so in using that notation, recognizing these two solutions are identical except for the plus or the minus in the center of each solution, we could rewrite this as the solution set is the set negative 7 plus or minus 2i root 10.